Esther Trufan, and in this video, I'm going to demonstrate how to collect a full visible spectrum of any solution that has color. For today's experiment, we're going to use our Kool-Aid solution that we originally prepared. We're going to dilute it by half with some deionized water, and to measure out 1.5 milliliters of each of these two, we're going to use two 10 milliliter graduated cylinders. And for such small amounts, it's always advisable to use pipettes with a bulb to control the added volumes more carefully. And then finally, to collect our spectrum, we will need to place the two solutions inside a cuvette. And I have my cuvette here. Because this is an aqueous solution, we can use a plastic cuvette. First, we're going to measure out 1.5 milliliters of the Kool-Aid solution. We discard the excess. Then we're going to measure out 1.5 milliliters of the deionized water. When the meniscus of the water is at 1.5 milliliters, we stop. Any excess will be discarded in the waste container. Once we measured out everything, we prepare our cuvette. We add the Kool-Aid solution, and then we add the water. Then we place the cap on top, and then we place the cuvette inside the spectrophotometer so that the clear sides of the cuvette are going to face the green lamp symbol. Then we're going to turn on our spectral analysis app, and we are going to say new experiment, absorbance versus wavelength. It will bring up this screen that has the visible range on the screen, and then we push collect. And at this point, our data collection will be done in less than a second. What we'll notice then is that we have a high peak that we can identify either by toggling along the wavelength axis, or we can go down to the bottom and look at the value associated with the highest absorbance. Once we find the highest absorbance value, then we identify the wavelength associated with that. After we stop our data collection, you will notice that the absorbance values are no longer changing, and now we can identify the maximum, which in our case is 0.851. It is associated with the 494 nanometers. And with that, we know where our red dye absorbs the most light, and it allows us to monitor the kinetics of any experiment done with this particular red dye, because we can set the wavelength to 494 nanometers and then simply monitor the disappearance of the peak at that wavelength.